Right, start us off this morning to go back to isomerism. First little task for you. How many isomers? I want you to draw in whatever way you can. How many isomers can you make of the compound that I've got on the projector there? C3H6Cl2. Okay. I've taken it down. I was going to do a big longer one and I was like, oh, there's too many. The number of isomers in here, definitely less than 10, probably not more than 5. Okay, C3H6Cl2. I'll give you a few minutes to come up with however many isomers you can. Up to you how you do it, displayed or skeletal, whichever you think is quicker. Okay, but be careful that they are actually different. How many isomers of C3H6Cl2 did we come up with? You got 4. I think you're possibly right, so let's have 4 different people to come and draw however they want to draw it nicely on the board for us. Go on, Leanne, your hand went up first. Fantastic. Let's see if we get them all right. Okay, cool. Perfect, thank you. So we've got a propane chain with 2 chlorines on the same carbon atom at the end of the chain. Ahmed, go.
I'm not sure if that would be different, but...
Nice and big so we can see it. That's probably big enough, to be fair. Yeah, okay, that's absolutely different. So 2 chlorines again on the same carbon atom, but this time on the middle carbon atom. Good. All right, what have we got next? We've definitely got 2 more. Who's going to volunteer? Or alternatively, who am I going to pick? Jemima, go. There you go. Okay, so this time on, thank you, separate carbon atoms. So we've got 1 at the end, 1 in the middle. Okay, there is 1 more. Maria? Excellent. Okay, so this time separate carbon atoms, but at either end of the chain. Perfect. Okay, so you can do isomers now. I think you've kind of got that, and we keep practicing it throughout. Okay, you will definitely keep doing isomers. What I wanted to go on to today was nomenclature, how we are actually going to name all of these things. So ideally, well, probably in the next couple of minutes, you'll be able to name all 4 of those compounds. Okay, it's actually really, really easy to do. There's just a few rules that go with naming things, okay? So we'll go through the rules and then we'll do a whole load of exercises on how we name things. Guess I should have the right date today first, 9th of Jan. So we are looking at nomenclature. Say again? With redox? Yeah, we did, absolutely. So that was nomenclature for inorganic compounds using oxidation states. So this will be nomenclature for organic compounds. Okay? So nomenclature is the art of naming compounds. And it is an art. So organic compounds use the IUPAC systematic naming system. yeah, organic compounds use the IUPAC. IUPAC is the name of an organization. I couldn't actually tell you off the top of my head what it stands for. International something. But we need some rules. Let you write for a sec. Okay, so rule number 1, which you kind of know already from what you've done in GCSE, it's about finding the longest possible chain of carbon atoms, okay, in your molecule. That's going to give you the main part of the name. And what you know already, hopefully I'm not going to have to write it down, 1 carbon is meth, or meth, 2 is eth, 3 is prop, 4 is bute, 5 is pent, 6 is hex, 7, hept, 8, oct, 9, non, 10, dec. Okay, and to be fair, you won't really need to ever go past that. Okay, and in all reality, you probably won't even need to go up to like non and dec either. But knowing all of them from 1 to 8 is really important. So meth, eth, prop, bute, pent, hex, hept, and oct. Okay, those first 4, which are kind of can confuse people because they're not, they don't relate to anything else. But once you get to pent and hex and hept and oct, then they relate to like shapes in maths. Okay, so let's actually think about this for a second. If I do some nice skeletal formulas, then let's see what the longest chains actually are. I won't draw the H's on that displayed one. Okay. So all I want you to come up with in the next couple of minutes, I've got 2 skeletal, 1 displayed. Just work out for a second what's the longest chain in those. Okay. You might want to draw them as well, it's up to you. But give it a go. What can you find? I love the whispering. You're all whispering as to what they might be. You can talk in normal voices. It's okay. So even if you're not sure of the name, just find the number of carbon atoms. Okay?
Yeah, but you mean to go from there and then down and ignore the one on the end.
But you've got to make it the longest possible.
But wouldn't it go like that and then down? Suppose A, when it goes down, that counts as 3, right? To the top or the middle or
Now we've got some debate going on. That's good. 7, 4, 8. Okay. So, and what would the name be in that case?
7 on 10.
Yeah. Good. Okay, you ready? Ready to have a look? All right, let's look up then. So, for A, okay, we can count and actually find out together. So, there's a couple of different ways you could go, 3 different ways you could go, really. Okay, but if we go 1, 2, 3, 4, 5, 6, that's one possible. There's a chain of 6 there. If I go this way instead, to go 1, 2, 3, 4, 5, 6, 7. Okay, that looks like it's probably the longest chain. You could also go this way, 1, 2, 3, 4, but that's definitely shorter. Okay, so the longest possible chain is down here at 7. So in the name, the main part of the name is going to be, if it's 7 carbon atoms, it's going to be some kind of heptane. Okay? B, there was a reason I did this, and I'm pretty sure you picked it up straight away. Let's find out. What's the longest chain?
Back to A, sorry.
Back to A, sorry, yeah, go on.
Yeah, the main part is heptane, but what about the, is it 5-methyl?
We're going to come to that, but all I'm doing at the moment is the first rule, okay, which is about finding the longest chain, yeah? So in this one, what's the longest chain? 4, exactly, okay? But just be careful, okay? Doesn't matter what angle this last carbon comes off at, okay? It's still the same chain. It's not a branch. But it's the kind of thing that happens in exam questions. Not to, I hate it when students say, oh, it's a trick question. It's not to trick you, but it is just to check that you understand what's going on, okay? Nothing in an exam is ever there to trick you, all right? But anyway, longest chain in that one is 4, so that would make its name butane. Exactly. Okay. This one's a little bit more interesting. Okay. What have you come up with? Ziad? 8. Okay, let's just check how you did that. So 1, 2, 3, 4, 5, 6, 7, 8. If you go the other way, go from this end, 1, 2, 3, 4, 5, 6, 7, and 8. Okay, very good. So that would be some kind of octane in that case, yeah? Perfect. Okay, that's rule number 1. Finding the longest possible chain. Okay? Next. Yeah, that's good. I so meant to go and get a new board rubber today. But then the morning was ruined by the fact that we had no Wi-Fi for most of the morning. So the next rule is about, let me just check which order to do it in. Oh yeah, prefixes and suffixes. Okay, hopefully you know from English, don't you, what a prefix and a suffix is. Okay, prefix goes at the start of the word, suffix obviously goes at the end of the word. Okay, and there are a number of different ones that we're going to need. Okay, they kind of get introduced as well in each topic that we do with different functional groups. So if I don't do a perfectly exhaustive list right now, forgive me, but they will all come up. Okay. So in terms of prefixes first, okay, then prefixes generally come from branches first. Okay, so if you have a branch on the carbon chain, it needs to go in as a prefix. So for example, if your branch is 1 carbon, it will be called methyl, and that will be as a prefix. Okay, if it's a 2 carbon branch, then what do you think it's going to be called? Ethyl, exactly. And a 3 carbon, we don't often go much bigger than 3 on a branch, but go on. Propyl, exactly. Okay, so they come from the same stem names as methane, ethane, and propane. Yes? So, what do I mean by a branch? So, on this, okay, the longest chain that we can make is 1, 2, 3, 4. But it also has a branch coming off of it. Okay? That's what I mean by a branch. Is that okay?
And why, like, you know how it had to be the last one, so C, and then one down?
Yeah, so that would have been a branch. If it was 1, it would have been a methyl branch.
Why do you say
Because I was just doing the longest chain at that point. That's all, okay? Just want to build up the rules nice and slow for you. Okay? Other prefixes, most common one is for the halogens. Okay? So in that case, prefixes, so if it's chlorine, we have chloro, bromo for bromine, and iodo for iodine. I guess I should have started at the top. Ooh, terrible writing. But fluoro. Okay? Chloro, bromo, iodo, fluoro. You might have heard of, don't know how much you would have heard about it, but you might have heard of chemicals called CFCs before. They used to put them into aerosol cans, and they were the chemicals responsible for damaging the ozone layer. Yeah? CFCs. CFC stands for chlorofluorocarbons. So they're compounds that contain, they're little hydrocarbons that contain chlorine and fluorine. Okay? Factoid for you. Love a good factoid. Next, few suffixes. The main one, actually, that we use during year 12 is for the alcohol group. What's the suffix? I bet you know this already anyway. What's the suffix for an alcohol group? Ol, exactly. So we just change the name to ol. Okay? That group on its own, just so you know, is called a hydroxyl group. So if we talk about things that have a hydroxyl group, then we're talking about alcohols. Okay? The other ones we might come across a little bit during year 12, carboxylic acids. And again, that was in triple science chemistry. What's the suffix for? Oic acid, exactly. So it's oic acid. Is there one more that we'll possibly come across? Yes, I guess so. Don't worry about what it is for now, but something called an amine group will also have a suffix, and it's not a very difficult one because we just call it amine. All right. There's quite a bit in there. So we've got prefixes for branches: methyl, ethyl, propyl. Halogens are prefixes as well, so chloro, bromo, iodo, and fluoro. And then we've got some suffixes. Ol for alcohols, carboxylic acids are oic acid, and amines. Okay. That's a good set of rules there. But next, and this is probably the important one, if we go back, and we will go back in a bit to our starter and have a look if we can just actually name them all, we need the last rule. Can't do anything without the last rule. But has everyone got what they want from this bit? I should really have typed it on a PowerPoint, shouldn't I? One day I'll become efficient and make more PowerPoints. For now, we'll make do with videos. Okay, yeah, I'll leave the last bit. So the last important rule is what we call locants. Funny words, actually, to be fair. Okay, but locants are numbers which are going to locate where different groups are on the molecule. Okay, so So, we need a number to locate where our groups are. Best way to put it first is at the end of the chain, it's carbon number 1. But obviously chains have two ends. That is, I guess, the major characteristic of a chain. It has a beginning, it has an end. Okay? You have to decide which one is going to be the end. Or which one is going to be the beginning. Probably I should say, which one is going to be number 1. And we always choose number 1 so that our numbers are as low as possible. Okay? You're going to see this in just a sec, don't worry. Okay, so the end of the chain is number 1. The chain is numbered, to keep numbers as small as possible. Okay, so we've got the main length of the carbon chain. We've got prefixes and suffixes. We've got locants. Oh, I should just have one more as well. Because we can have multipliers in the name. Again, you're like, what? Multipliers? What are you talking about? If we have more than one of the same group, then we need to put multiplier in. If I have two of something, what do I say it is in that case? Huh? Die, exactly. If I have three of something, what am I going to say? Try. Okay? So usually it's die and try. It is possible to have a 4 as well. Tetra. Exactly. Yeah, it's not quad or anything like that, it's tetra. Okay, and if you remember back to what you've done on shapes of molecules and so on, you've done about tetrahedrons. Yeah? 4-sided pyramids. Yes, 4-sided pyramid. Okay? So, multipliers when there is more than one of the same group. So, di is 2, tri is 3, and possibly tetra is 4. Okay. I'm not going to write it down. If you did want to go up, di, tri, tetra, penta, and hexa. Okay. But I'm not writing that down. I don't expect you to write it down either. Okay. It's a whole ton of writing so far today. And lots of new information to assimilate as well. Let's go back. I'm going to take the top part off. We go back to our starter, then C3H6Cl2. We had a number of different isomers. I'm going to start with this one. So that was one of the isomers that you picked, or that you made, for C3H6Cl2. If we use all of those rules, we can name it. Okay? I'll help you though, don't worry with this one. So, first off, we use rule number 1. What is the carbon chain? How long is the carbon chain? 3. So what's its name? Propane, yeah? So propane is basically going to be the end of the name. We've got... Have we got any branches, by the way? No, so we don't need to worry about any branch names, that's good. But we've got these chlorine ones here. What does chlorine make? What kind of prefix or suffix does it make? Chloro. Is that a prefix or a suffix? Prefix, okay, it's a prefix. So this is going to be chloropropane.
There's 2, right? So.
Okay, yeah, there is 2. So what am I going to put with it? Dichloropropane. Good. But dichloropropane could be any isomer of C3H6Cl2. It's only the locants, the numbers, that are going to tell us which particular isomer it is. Okay? So, thinking about this chain, we don't really have much choice when it comes to a propane chain, but what will the numbers be, do you think? 1, 1 and 3 for this one. 1, 3, dichloropropane. And I put 1, 3, dichloropropane. There is a comma between the numbers, yes. Okay, so the locants part. Okay, I need to look at the chain. Now, for propane it doesn't necessarily matter, but this is carbon 1, carbon 2, and carbon 3. One of my chlorines is attached to carbon number 1. The other chlorine is attached to carbon number 3. So I go 1, 3, di, because there's 2 of them, chloro, because they're chlorine, propane, because I have a chain of 3. Yeah? So, your task for the next couple of minutes, and it wouldn't actually be that tough now, I don't think, but go back to your isomers that you made. Make sure that you can give all 4 of them names. Okay? Work. So, those isomers, we already did one. It was 1,3-dichloropropane. To be fair, they're all going to be dichloropropane. They've just got different numbers with them. Okay? So, the question more becomes, what are the combinations of different things that we could have? Okay? What did you come up with? Tell me. Yeah? One dichloropropane. Almost. We wouldn't call it 1-dichloropropane. We need to have, if it's di, we need to have 2 numbers. So it needs to be 1,1-dichloropropane. Even though they're still on the same one, you need to show where both of them are. So 1,1-dichloropropane. Okay, so we've got 1,1. What's another combination? We can have 2,2-dichloropropane. So now we've got 3 isomers. The only other combination possible is, not 2,3. We would make it 1,2. Okay? Because we want to keep the numbers as low as possible, we can't make it 2,3-dichloropropane because those numbers add up to 5. But if we make it 1,2, the numbers only add up to 3. Yes, I did have to think about what 1 and 2. Yes. Okay, so to keep challenging you, I've drawn up, while you've been working, 4 different compounds here. Okay, full displayed formula for you. What I want you to do is to name them. And I really need you to think about the way that you're going to number things. Okay, you want to keep the numbers as low as possible. If you've got two different prefixes, then you probably want to put them in more or less alphabetical order. Okay. Also, if you've got a suffix for a group that needs a number, the number needs to go right next to the suffix. So you need to break up the word and put a number in the middle of the word. Okay? So that's particularly for the first one. You're going to need to break up the word and put the number right before what the suffix is. Okay? See what you can come up with. So we've got 4 compounds there that can all be named with the amazing knowledge you've gained this lesson. See what you can come up with in the next few minutes. Okay? Right, folks, we've only got a couple of minutes left. So let's come back and let's try and work out some of these names. They're interesting. We want to be as systematic as possible about this. I think most of you have got this. It took a little bit of help with some people. Okay, we've got a 4 chain, or chain of 4, so definitely butane. What does the OH group give us? Gives us ol. Okay, so butanol. But we need the locant, we need the number, because it's possible the OH group could be here or here. Okay? So it's butan 2-ol. Okay? Written like butan 2-ol. I would normally do it with little dashes in between. Okay? That was supposed to be the easy one. Go on.
So if I wrote 2 butanol.
2-butanol is not really right. Okay, we need to, when we've got the numbers, we need to keep it with what it's talking about. So the 2 is for the ol, for the alcohol, so we keep it right there, so we know exactly what it is. Because if we had another functional group, then it's going to start to get confusing for you. Okay, so even though we've just got one, we keep it together. Okay, I'll go across to this one. Wow. So what's our chain here? We've got 1, 2, 3, 4, 5. Or 1, 2, 3, 4, 5. Fine. So it's the 5 chain. What's that going to make the actual, Angie? Pentane, okay. Do we have any suffixes with pentane? Do we have any suffixes there for the groups? But is it a suffix or a prefix? It's a prefix. So we can actually just write in with no suffixes, we can go straight away and get pentane. We know that part. But we've got 2 groups. We've got a bromo. I'm being good to you now. We've got the bromo here, and we've got the branch. Okay? So this is going to be, well, we've got bromo. What's this part going to be called? Methyl. Okay, well, we can kind of put that in. It's going to be bromo methyl pentane. But we need numbers now. Okay. For the bromo, 1. Okay, 1 bromo. And then for the methyl, not 2. If this is 1, then this must be 4. Okay? We can't suddenly switch which end we're numbering from. We always have to go one direction or the other. So this would be 1 bromo, 4 methyl pentane. Okay? And we wouldn't number it the other way because that would give us 5 bromo, 2 methyl. And the numbers add up to 7. It's much easier to have numbers that add up to something smaller. So that's how we do it. 1 bromo, 4 methyl. And in alphabetical order. Okay? So, last 2. This one now, I reckon you can give me an answer very quickly. Go. Huh? Propopentane. Okay. I'm not convinced of your chain length or that much, unfortunately, with your answer. I know that's harsh. But what's the longest chain first? Propane. Thank you very much, Leanne. Good. It's a propane. Go on, Leanne. The whole name if you want. Not quite. Not ethyl. It is dimethyl. So 1, 2, 3 is the longest chain. There's a methyl group there and a methyl group there. There's 2 of them.
But didn't she only have 2 carbon branches?
No. If the branch is 2 carbons long, but there are separate branches, only 1 long.
So, like for 1 to carbon, you have to have another carbon branch down there.
Exactly. I'm going to have to finish, and I'm not going to finish the last one, but that 2,2, to be really good about it, 2,2 dimethyl. Oh, you made me write pentane because I was thinking about it, Ziad. Sorry, guys. Propane. 2,2 dimethyl propane. Okay. Perfect. Good. Let's stop it there. Thank you very much.